Bismillahirrahmanirrahim. Last time we talked about congruent triangles and congruent polygons in general, and we suggested that two polygons are congruent or two triangles are congruent because triangles are one example of polygons. So two polygons are congruent only if all their corresponding sides are congruent and all their corresponding angles are congruent. And we use that to prove triangles to be congruent. In other words, we said that if you have two triangles, they are going to be congruent if two conditions are met. That is, all their corresponding sides are congruent and all their corresponding angles are congruent. So if you have two triangles like this over here, these two would be truly congruent. They would be congruent if we can prove that all the sides, corresponding sides like these, are congruent. And if we, at the same time, if we could prove that all the corresponding angles are congruent, that is, this angle would be congruent to this angle would be congruent to this angle, and finally this angle would have to be congruent to this angle. So if we wanted to prove these two triangles congruent, we would have to show that all the corresponding sides are congruent and all the corresponding angles are congruent. Now, that's a tall order. In other words, that's a lot of things to prove, right? It's like, 6 pairs of things that we had to prove, 3 pairs of sides and 3 pairs of angles that we have to prove to be congruent to just show that two triangles are congruent. That's a lot of work. So the question is there any easier way of proving triangles congruent? Well, of course, there is, and that's what we shall explore in this section. In this section, we shall explore 2 other ways besides proving all the sides and all the angles to be congruent to prove that the angles are congruent. And in this section precisely, we shall learn about the side, and the side angle side postulates. That's what that stands for. SSS, SAS, side, angle, side postulates, and we're going to use those postulates in proving triangles to be congruent. So first I am going to explain to you the postulates, and then we shall inshallah do some examples. Okay, so here is the first postulate. Now, these are both going to be postulates. In other words, we're not going to be able to prove that these are true. So this is the first postulate we're going to learn today, and this is the side congruence postulate, or side triangle congruence postulate. Sometimes we just say side, but you have to actually understand what that means. If I ask students, okay, why are these two triangles congruent? They say side, and ask them what does side means. They are not able to articulate what exactly that means. So side means side congruence, triangle congruence postulate, precisely. That is, the postulate specifically says the following. Okay, here it is. If 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. In other words, if you have 2 triangles like here, if 3 sides of the first triangle are congruent to 3 sides of a second triangle like this, okay, then the 2 triangles are congruent. So this postulate says don't worry about the angles, they're going to have to be congruent, okay? So it's like that. So instead of proving that all the sides and all the angles are congruent, we just have to prove that all the sides are congruent, and then we are done. We've proved that the 2 triangles are going to be congruent. So you should know what side triangle congruence postulate. If I were had option, actually, I would put a little triangle over here to make it precise wording. So side triangle congruence postulate, or just side. After a while, we use this so much that we just say side. So, side triangle congruence postulate states that if you have 2 triangles, if 3 sides of one triangle are congruent to 3 sides, if 3 sides of one triangle are congruent to 3 sides of a second triangle, then the triangles are congruent. So in this case, we have triangle ABC, and we have triangle DEF. All right, so, and these 3 sides are congruent, then the 2 triangles are going to be congruent. Now, be careful how you write the statement of the fact that the 2 triangles are congruent. Here we said triangle ABC. Now, starting from A going towards B, then you have to be start at the right starting points. In other words, if you start here at A and go towards B, A, B, C, you can't start here at F and go in a random way, go to D or something like that. You have to find which vertex corresponds to A. Well, A is between these two sides, so that's going to be D. So A corresponds with D, and you're going towards this side, which is the one tick mark side like this. So it's very important to, when you're writing your congruent statement, that your starting point is correct, and your directionality in which direction you're moving is also correct. So you just can't say ABC is congruent to FDE or EDF or something like that. You have to make sure that the starting point is the same for the two triangles, are corresponding angles, and you're moving in the right direction. So it would be correct to say triangle ABC is congruent to triangle DEF. Now, if you wanted to start somewhere else, you could do that. Let's say if you wanted to start from side B and go this way, then you could say triangle BAC. Now, which angle corresponds with B? Well, it's the one between 1 and 2. That's E. And then if you're going towards the one side, going this way, right? So you could say triangle BAC is congruent to triangle EDF. Okay, so that would also be correct. So you just have to make sure the starting point is the same, and the direction of that you're going is also the same, and you're making these important congruence statements. So this is the side congruence postulate. That's easy enough. The next postulate that we learn, and I'm going to just share that with you before we do some examples, is this one. This one is side angle side congruence postulate. So side angle side triangle congruence postulate, or side angle side congruence postulate. Okay, SAS. Now, this one states the following. Okay, now you have to understand something very carefully here. All right, this one states if two sides, not three sides. I mean, sometimes it can be tough to get three sides and to prove three sides to be congruent. So let's see if we can get away with two sides. Well, if two sides of a triangle are congruent, so we have two sides. If two sides, but then here says we have to have an and statement. If two sides and include an angle. So what does that mean? See, if you have every angle, if you recall, has two sides, and the angle that's between these two sides, that's called the included angle. So if you have two sides of a triangle and the included angles, in this case we have this side and this side, okay, and the included angle here would be angle A, okay. So included angle are angles that are between those two sides. If you have those two sides, that's the included angle. Now if you're talking about these two sides, that's the included angle. So the included angle is just the angle that's between those two sides. So if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. So what this states, that if you ever run across two triangles such that two sides are congruent like this, so this side is congruent to this side, and then you have this side that's congruent to this side. So you have two sides that are congruent, all right? And the included angle is congruent. That is, the angle between these two sides is also congruent between these two triangles. Then the two triangles are congruent. That's why this is called the side angle side. Side, angle, and side. So side angle side triangle congruence postulate. So side angle side postulate. So we have side congruence postulate, side angle side congruence postulate. So that's easy enough, right? But you should really be able to articulate these clearly. So if you just can't say side angle side and not know what that means and not know how to be able to articulate that. So the side triangle congruence postulate states if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. And the very important side angle side triangle congruence postulate, or side angle side congruence postulate, states that if two sides and the included angle, if two sides and the included angle of one triangle are congruent to two sides and the included angle of a second triangle, then the triangles are congruent. So this is side angle side, side angle side. Okay, again, you have to be careful in how you state the congruent statement. You just can't start anywhere. You have to make sure you start at the right starting point and go in the right direction. Here, as I read BAC, so start with angle B and you're going towards A. So which angle or which vertex corresponds to B? Well, it's this vertex, and you're going towards this angle over here. So side, angle, side. So the reason I wrote it like this is because you tend, the angle D is like the middle angle here, angle A and D. So I put that in the middle, so that way you know side, angle, side. It's just kind of a neat way of putting it. Although you can write multiple congruence statements, we just tend to write side, angle, side like this, whichever one corresponds. So B, A, C, the way you would trace the triangle if you were to use side, angle, side. So these are the two postulates that we are introduced. Fortunately, there's more. There are other ways also of proving triangles congruent, in which we shall discuss in the future. But now let's do some examples using these fantastic postulates, inshallah. Okay, so here's our first question, and here we're asked to write a flow proof. If you recall, a flow proof is kind of like your thoughts, and written in a paragraph form. A proof like written in a paragraph form. So fine, let's see what we got here. Okay, so this is a given information. So now, when you read this, you have to be careful. A lot of times when I ask students to read this, they would read something like this: GH is congruent to KJ, HL is congruent to JL. No, that's not what that says. What that says actually is segment GH is congruent to segment, because you have to put that little, recognize that little segment symbol. It's not ray, it's not, line or anything like that. It's segment. Segment GH is congruent to segment KJ, and segment HL is congruent to segment JL. That's one thing. So you have to read this properly. The second thing is, if you're given a figure like this and you use the figure, mark information using tick marks on the figure, it will help you visualize the problem. So alright, so let's do that. So segment GH is congruent to segment KJ. So segment GH, which is over here, is congruent to segment KJ, which is over here. Got that. And segment HL is congruent to segment JL. Segment HL is congruent to segment JL, like this. And then L is the midpoint of GK. L is the midpoint of GK. So if L is here, over here, and GK is the big one over here, so we can say if L is the midpoint, then we know these are congruent, because that's what midpoints do. Definition of midpoints is divide the segments into two congruent segments. So now we are asked to prove the triangles GHL is congruent to triangle KJL. And that's easy, right? Because what? We have side, triangle congruence postulate, which states that if three sides of one triangle are congruent to three sides of a second triangle, then the triangles are congruent. So it's a pretty easy proof, and you can write this as a flow proof by saying, okay, given this is congruent to this, and we can say that GL. So as the flow proof would be, you would have the given information. So this is congruent to this, and then you say that. So say GH is congruent to KJ, like this, and HL is congruent to JL. So this is so given this, and then you can say L is the midpoint. Okay, that's all given. In midpoint of segment GK. Okay, given this information. Okay, therefore, okay, GL is congruent to KL. Okay, by definition of midpoint. Okay, midpoint. Does, okay, triangle GHL is congruent to triangle KJL by side triangle congruence postulate. There we go. That's it. That's all it is. And that's a flow proof, and it'll be just as easy to write, I believe, a two-column proof over here. So this is an easy example to begin with. Let's see what we have next. Okay, here it is. Given triangle QRS is isosceles. Isosceles are triangles that have two congruent sides like that. Okay, so isosceles. Okay, got that. Thank you very much. So triangle QRS is isosceles with QR is segment QR being congruent to segment SR. So QR is congruent to SR like this. Okay, that's very good. So yeah, that's isosceles triangle. All right, so we have that. Okay, segment RT. I don't know if they meant to say segment or ray. They just made this a little ray here. Fine, we can deal with the rays. They're friends. So rays are our friends. So RT, segment RT bisects QS, okay, at point T, which means basically divides this into two. So that's what it means for a segment to divide another segment in two, to bisect. It divides it into two congruent parts. So we are to prove that triangle QRS is congruent to QRT. So we are to prove that this triangle is congruent to this triangle over here. So those two triangles, like so triangle, we can do it. So now, so far what we know, how do we know to prove triangles? We know to prove triangles by definition of triangle, that is, the three sides and the three corresponding angles are congruent. We know to prove triangles by side, and we just learned side, angle, side, although we haven't used it yet. So those are the three ways that we know really of proving triangles congruent at this time. So we're going to have to use one of these three ways. Well, this is very difficult because it's a lot of labor intensive. You have to prove all three sides, all angles. That's what we're doing anyway. So these other ways are going to be easier. So right now, therefore, we have only two ways in essence of proving triangles congruent. Side, angle, side. Okay. So now we're not given any angles here, but we're given these two sides. And it bisects, so we got those two sides. We need this third side, but this third side is common to both triangles, isn't it? So it's part of this triangle, it's part of this triangle, but because of reflexive properties congruent to itself. So it's going to be pretty easy proof here. Again, this is a flow proof, so we say that, okay, QR is congruent to SR. This is given information, okay? So is given, okay? So here's our proofs, is given information. And then we can say QT is congruent to ST by definition of segment bisector, okay, and given information, and given that RT bisects QS. Okay, so now we got those to be congruent. And then we have to state the reflexive property, and by reflexive property, okay, RT is congruent to itself. Darn it! So here it is. So RT is congruent to itself. Now we have three sides. Okay, then we can say these two triangles are congruent. Therefore, triangle QRT is congruent to triangle. There should be a triangle symbol here. SRT by side congruence postulate. After a while, we'll just say side, but here I'm just saying side congruence postulate, so we become comfortable using those terms. That was pretty easy, right? Side angle congruence postulate. Okay, let's see what we have next. Okay, so here's our next question. The given information is this. This is like a kite thing. So FG is congruent to GH. Okay, that's given to us. Those two are congruent. So notice how that segment FG is congruent to segment GH. How I put the tick marks. I'm using the diagram to help me think. And then I said segment GJ, that's this over here. Segment GJ bisects angle FGH. So here's FGH. That's the big angle over here. So angle FGH. So this little segment bisects the big angle. That means that it divides the angle into two halves. That's the definition of angle bisector. So it divides that angle into two halves. So those are two congruent angles. And then we are asked to prove that triangle FGJ, that's FGJ, this triangle, is congruent to HGJ, that this triangle here. So we have to prove those two triangles to be congruent. Well, how are we going to do this? Now, now let's see, what am I going to do? I don't know. What do you think? I don't know. Well, side or side angle side, right? well, you're beginning to appreciate that these reflexive property of angles are very useful, isn't it? Because GJ or JG segment is congruent to itself by reflexive property of congruent segments. So then we're done, because we have side, angle, side, and we can use side, angle, side congruence postulate to prove, because we have side, angle, side, angle, side. Done, pretty much, right? So all we have to do is, if you wanted to write this out, let's write this out as a 2-column proof over here. So which means that we have to draw 2 columns over here. So let's do that. Here we have the statements, and then here we would have the reasons for making our statements. So the first statement's given. When in doubt, just write the given. That is, here would be FG is segment FG is congruent to segment GH. That's given. Okay, so here I write that. Number 2, I'm going to write it separately, okay, because because GJ bisects angle FGH. It bisects the big angle. That's also given information. And then I can say, those 2 angles are congruent. So I can say angle FGJ is congruent to angle HGJ, and this is because of definition of angle bisector. That's what angle bisectors do. They divide the angles into 2 congruent angles. So that's definition of. So now we have that. Now before we put the triangles congruent, we have to use a beautiful reflexive property. GJ is congruent to itself, right? Just because of a reflexive property of congruent segments. There we go. There we have it. And finally, we can say, now that we have side, angle, side, we can say triangle FGJ is congruent to triangle HGJ, and this is because of side, angle, side, congruent, triangle congruence postulate. There we go. That's pretty cool, right? I thought those were very interesting, easy, hopefully question. As you can see, reflexive property is very, very useful. Okay, so here's our final example for the day. It's from your textbook again. Here's the given information. Segment BC is congruent to segment DC. So BC is congruent to DC. You got that? All right, so angle BCF is congruent to angle DCE. So be careful. BCF. So this angle right here. Whoa, that's interesting. That's a nice big angle. So BCF is congruent to angle DCE. That's this angle over here. That's very interesting information. So that angle is congruent to that angle over here. And then we are also told that FC is congruent to EC. That's this over here is congruent to EC over here. Now what we're asked to prove is the following. Prove angle CFD. Angle CFD. We are asked to prove that this angle CFD is congruent to angle CEB, this angle over here. Wow. Okay. Well, what's going on over here? So we're asked to prove that this angle is congruent to this angle over here. So that's what we are asked to prove. What in the world is going on over here? You say, what? I thought we were talking about triangles, and here you're asking to prove that the angles are being congruent. Well, how do we go about doing that? We didn't learn anything about proving angles congruent. Well, we did, kind of, in a sense. Well, how do we do this, you think? Well, we have to prove that those 2 angles are congruent, but there's a little bunch of triangles here, right? Well, imagine if we could prove this triangle to be congruent to this triangle over here, this little skinny triangles on either side. If we could prove that those 2 triangles are congruent, then this angle has to be congruent to that angle, because those 2 angles are part of the 2 skinny triangles, aren't they? Why would they have to be congruent? Well, if 2 triangles are congruent, then all the corresponding parts of the triangles are congruent. In fact, we learned that very famous statement last time, CPC TC that you must know. Corresponding parts of congruent triangles are congruent. That is, if you can prove the triangle's congruent, then not just those angles, for God's sake, all the corresponding parts of those two triangles are going to be congruent. So CPCTC is going to be very useful to once we prove the triangles to be congruent, to prove that all the corresponding parts of interest, or whatever they are to us, are going to be congruent. So our goal here would be to prove that those two skinny triangles on the sides are congruent. If we can do that, then we can prove those two angles to be congruent. So how do we do that, though? How do I prove that this triangle is congruent to this triangle? Well, again, we have like three things to it. We have definition of triangles. That means all sides and all angles. Well, that's kind of hard. Then we have side, 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 and we have side, angle, side. Well, we have two sides, and if you can somehow prove that this side is going to be congruent, then we can prove by side, 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 actually. Okay, that's one option, maybe, but I don't know how we're going to do that. You know what I'm saying? Well, but what about this information over here? What about these angles? How do we use those angles? Well, maybe, well, see, this angle is congruent to this angle, right? That means, you know what that means? I'll tell you what that means. That means this angle is congruent to this angle, right? Because you can subtract out this angle, don't we? Because if you have these two big angles are congruent, you subtract the ECF angle, the middle angle over here, then those two sides are triangle. That's going to be the case, right? So, for example, how do we know that? Because we're given that angle BCF is congruent to angle DCE. That means that angle BCF, okay, and minus angle ECF is going to be congruent to angle DCE minus angle ECF. That is, if you take away the same angle from both sides, the resultant has to be congruent because of subtraction postulate for congruent angles. Remember, if A is equal to B, then A minus C is equal to B minus C. That's for rational numbers. That's the property of rational numbers. So, subtraction property of real numbers. Subtraction property of real numbers states that if A equals B, then A minus C equals B minus C. In the same way, the subtraction property of congruent angles states that if two angles are congruent, then if you subtract the same thing from both sides, that's going to be congruent. So that's beautiful. That way we can get those two skinny angles to be congruent, and then we can get side angle side. So this is a very beautiful question in my mind, and it's worth doing it well. So I'm going to try to do it here in statements in a two-column proof, and statements and reasons. Alright, so let's just do this. So given information, so BC is congruent to DC here. That's given, darn it. Okay, so we got that. It's easy peasy. Then I can say, I'm just going to put all the segment. Well, I'm going to just do the angles, as we said. We just go in order, side, angle, side. So angle BCF is congruent to angle DCE. So there you go. And that's also given information. Now I could just say these two skinny angles are congruent, but then I can say a more elegant way of saying that is, watch. First I say ECF, that little middle angle over there. Okay, I say that ECF is congruent to itself. ECF, right? That's because of reflexive property of congruent angles. Okay, now you can see you can subtract the two. Then you can say, since we're given this, you can subtract the two. Alright? Now I can say, now beautiful, watch this. Now I can say angle, let me get the different color. Alright, so the two skinny angles over here, okay? The two skinny angles here. So that's angle BCE is congruent to angle DCF over there, two skinny. And that is from the subtraction property of congruent angles. That's beautiful. So now I already got that angle. Then I can say those two sides. I still need the side over there. The given information FC is congruent to EC over here. Okay, so that's 5. That's also given information. So now we have our side. Now we have our angle. Now we have our side. Side, angle, side. So that's our side. That's our angle, and that's our side. So we have side, angle, side. Okay, so that's like side, angle, side over here. Now we can say the two triangles are congruent. Now we can say triangle BCE is congruent to triangle DCF over here, and that's because of side, angle, side congruent postulate. In the future, I'll just write side, angle, side here. I'm writing the whole thing so we are familiar with it. We're not done yet. We are not done yet because we have to prove that the angles are congruent. So now we have step 7, which is what we want to prove. Angle CFD is congruent to angle CEB. See, that's what we're trying to prove. CEB, that's this. Okay, and they are congruent because, ta-da, CPCTC. That's all you do. You just write it down. So corresponding parts of congruent angles are congruent. And that's that proof. Now, a lot of students have difficulties with proofs because, it's kind of like thinking in a very logical, beautiful way. One of the most important things that you must do if you want to master the proofs is that the examples that you've given, you almost have to go through them until you memorize it, you feel comfortable with them, because same logical patterns will recur. So the examples you're given, you have to really look at them, watch them, observe them, write them out, go through the logic for yourself until you can visualize the whole problem in your mind's eye, until almost like you memorize the problem, and that will make it easy for you to do the proofs. Inshallah, next time we shall do more examples and add to our knowledge here. Until then, as-salatu wa-salamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.